my 4.3, properties of logs. I'm hoping you're feeling like this is a section I can tackle and it's not going to be tough. Same thing's going to happen here for us on the My Math Lab stuff. It will not be too difficult, I don't think. They start out by making sure that you understand the idea of a rational exponent. You put a radical on that, put the AB underneath there, and then the denominator is the index, that kind of thing. Let's look at the second little one up there, xy raised to the 5/6. Again, make a radical, put xy underneath there. The denominator is the index, and then the numerator will be what we'll raise xy to. Be careful, that's not the correct answer. That only raises y to the exponent. Remember, an exponent has only enough power over the guy next to him. We need to include x in that, so put it in parentheses, and then you're good to go. All right, let's expand these first ones out, 1 through 9. We're going to expand out based on what you know, what you learned from Thomas's 4.3. So we've got log base 12 of 7 times 5. Remember, if they're multiplied together, we're going to separate them out and add them. So log base 12 of 7 plus log base 12 of 5. Can you raise 12 to a number that'll give you a 7? No. 12 to a number raised that will give you a 5? No. So you're good. Let's look at number 2. Log base 16 of 16 times x. That's the product property. 16 times x, so we'll add them. Log base 16 of 16 plus log base 16 of x. This guy's going nowhere. You can't raise 16 to a number and make him be an x. But looky here, we looked at this several times in Thomas's. What can you raise 16 to make him be 16? 16 to the first power will give you a 16. So we can simplify the first piece, but not the last piece. And that would be the answer. Did a little bit of simplifying there. Let's look at number 3. Log base 16 of 16. Seen that somewhere. Oh, well. Log base 16 of 16 divided by y. This is a division problem, so we'll separate it out by subtraction. Quotient rule says you're going to subtract them. Log base 16 of 16 minus log base 16 of y. What can you raise 16 to make him be a 16? 16 to the first power will give you 16. And there we go. Got that. All right, number 4. Got common log, so you know there's a 10 there, of x over 10 million. This is a quotient, this is a division problem, so we'll treat it as a subtraction of logs. Log base 10 of x, there'll be no simplifying going on there. We can't make 10 become an x, minus common log of 10 million. Okay, keep this guy the same. What we've got here is, what do you have to raise 10 to make him be 10 million? 10 to the what power will give you 10 million? Well, 10 million is 10 to the 1, 2, 3, 4, 5, 6, 7. I'm thinking that was not. Hang on a second. Don't want to tell you wrong. Okay, I just remembered it wrong. So how many zeros are there? 1, 2, 3, 4, 5, 6, 7. So this is 10 to the 7th. When the bases match, the exponents match. So what that says is, what do you have to raise 10 to make him be 10 million? You'd have to raise him to a 7. So minus 7 there. So 7 is the answer to the log, to the common log of what do you raise 10 to make him be 10 million. And if you are not comfortable with that, and I get that, try it out on your calculator. You know, do 10 raised to the 5th power. Nope, that's not 10 million. That's only got 5 zeros. You want 7 zeros. So, and I know you can logic your way better through this probably than what I'm doing. I know you got different skills. 10 to the 6 has got 6 zeros. And so don't forget you've got this key up here too if you want to do 10 to the 7th power. Gives you, there you go, that's what you wanted. So you can play around with that rather than knowing it. Let's look at number 5. We've got log to the base d of x to the 3rd. So what this tells us is that we're going to have to sling that power in front. 3 times log to the base d of x. That's all we're going to be able to do with it because you can't put an exponent on d that'll make him become an x. Let's look at number 6. We've got the common log of r to the negative 6. And again, what we've got going on there is that we've got a power. Sling him in front. So negative 6 log, common log of r. We're good there. Let's move us down. Okay. Number 7, log base b of x to the 9th y. Ooh, there's some thunder. Getting an electrical storm. This is Saturday morning, the 28th, I guess, the 28th of March. I don't know about you, but I don't even know what day it is ever anymore. It's just all the same day. But we're having an electrical storm here, so I hope you are too. I love those. Hope your dogs aren't too afraid. So we're going to break this up. This is a multiplication problem, so we're going to be adding these two. So log base b of x to the 9th plus log base b of y. I'm going to sling that 9 in front. So 9 times log base b of x plus log base b of y. There's nothing we can do to make a b become an x or a b become a y, so you're good there. Number 8. We have log base 4 of 64 divided by the square root of x plus 7. Okay. Let's see. This is a division problem. So we're going to break this out by subtracting. So log base 4 of 64 minus log base 4 of the square root of x plus 7. A couple things we're going to need to do here. Let's clean this up. What can you raise 4 to that will make him be a 64? So remember, the answer to a log is always an exponent. So we're asked to find, what do you raise 4 to make him be a 64? Right here, yeah, we're still on the screen, good. And if you're not sure, go 4 humpy 2, that gives you 16. 4 humpy 3, that gives you 64. So this piece is a 3. Over here, let's see, we got log base 4. We need an exponent on this one, not a radical. So we're going to have x plus 7 raised to the 1/2. Remember, the index is the same thing as the denominator. And now that we rewrite that one with a power, we're going to sling that to the front. So 3 minus 1/2 log base 4 of x plus 7. And you're good there. You're just using a whole lot of different little skills to get each one of these little problems done. Okay, that looks good. Let's look at the last one that we are going to be expanding out. We've got log base g of the square root of x. We're going to have to turn him into an x to an exponent. Y to the 10th. He's already got an exponent on him. Z to the 3rd. Okay, we got 3 parts here. I'm hoping that you're recognizing that we're going to have to turn this to x to the 1/2. And then these will be added. This will be subtracted. And then we're going to sling each of those powers out in front of their problems. So let's see what we got here. Log base g of x to the 1/2, because the square root of x is the same thing as x to the 1/2, plus log base g of y to the 10th, minus log base g of z to the 3rd power. Let's see, you got that in there? Good. Now, sling the powers out in front. So 1/2 times log base g of x. There's no way we can turn a g into an x. Plus log, 10 goes out in front. Log base g of x plus 10 times log base g of y, and then sling that 3 in front, minus 3 log base g of z. Okay? Number 10, we're omitting number 10. Number 10 is just weird. I took it out of your homework because it's weird. And it just doesn't have anything to do with the skills that we're learning here. It's a thinking outside the box. Right now we're kind of staying inside the box, if you know what I'm saying. So 11, 12, 13, which isn't on here but is on your homework, so I've got it here for you. 11, 12, 13, 14, and 15, we're condensing. They have expanded them out. We're going to have to scoot them together, just like we did in Thomas's sheet. So number 11 is log base 3 of 189 minus log base 3 of 7. We have a subtraction problem here, so we know that turns itself into a division problem. So we've got log base 3 of 189 over 7. 189 over 7. Let's see what that'll do for us. 189 divided by 7. Oh, gives you 27. So let's simplify that fraction. We get log base 3 of 27. And let's see, what do you raise 3 to make him be a 27? 3 to the what power equals 27? 3 squared is 9. Nope, 3 to the third is 27. So the answer here is 3. What do you raise 3 to make him be a 27? That's a 3. Okay, number 12, let's squish that together. We've got log, common log, of 7x plus 12 minus the log of x. Not a whole lot fancy going on here. This is a fairly simple, straightforward problem. You've got a subtraction problem. You need to turn that into a division of logs. Log of 7x plus 12 over x, and we're good. Don't need that little piece of parenthesis. So 7x plus 12 on top, x on bottom. Okay, let's tackle number 13, which is not on my sheet. So let me show you what it is. 7 times log base b of x plus 4 times log base b of z. Okay, so this problem is not on your worksheet. I just left it off when I typed it up, but it is on your homework. So this is one like your homework. So let's see, we definitely have a multiplication problem happening here. But first we've got these powers to put in place. So this would be log base b of x to the 7th. Send this guy back where he came from. Send this guy back where he came from. Plus log base b of z to the 4th. So we've got the powers in place. Now let's deal with the multiplication aspect of it. Log base b of x to the 7th, z to the 4th. Put them in parentheses because it's more than one term that you want to include on the log. And you're good. Let's look at number 14. 4 times the natural log of x minus 1/5 times the natural log of y. Okay, so both of these involve powers. We'll sling those back up there. This 1/5 is a little bit new for us, I think. I don't think we did something like that on Thomas's. It's normally a whole number for us, but we'll deal with it. And then we've got to deal with the subtraction aspect. So let's sling these 4s and 1/5 back in place. Natural log of x to the 4th minus natural log of y to the 1/5. That's going to turn itself into the 5th root of y. Remember, the denominator and the index match. So this is the natural log of x to the 4th minus the natural log of the 5th root of y. This is a subtraction problem, so natural log of, we're going to be dividing them. 5th root of y, and you're good. Nothing more fancy we can do there. Let's look at 15. We've got 7 times the natural log of x plus 3 times the natural log of y minus 4 times the natural log of z. Nothing tricky here. It's just a full combo here. Let me make sure this is on there. Nope, I'm a little bit off, I think. Better. I'm going to there. Okay, good. So each one of these has a power that we're going to have to sling back behind the variable. And then we'll worry about the pluses and the minuses. So we'll have the natural log of x to the 7th plus the natural log of y to the 3rd minus the natural log of z to the 4th. Now let's deal with the product property and the quotient property. So natural log of, these two are added together, so they're going to be multiplied together in the log, and then subtracted from, which indicates division of logs. Let's see, that's number 15. Yeah, we're good. Okay, 16, 17, and 18, evaluate using a calculator if necessary. Boy, this is so much of a quicker stuff than we've been doing, yeah? Let's look at 16, 17, and 18. 16 is asking you to find the value of log base 14 of 20. What do you have to raise 14 to make him be a 20? 14 to the first power is 14. 14 to the second power is like 296, 196, something like that. 14 humpy 2 gives us 196. So if we're gearing for 20, we're way up here. We're almost just a little bit more than 1. We don't have a key on our calculator for log base 14, so let's do log of 20, common log of 20 divided by common log of 14. Common log of 20, close it out, divided by common log of 14 equals, we're getting approximately 1.1352. That 5 behind the 1 will raise this up to a 2. You could have done natural log for that if you wanted to. Natural log of 20 divided by natural log of 14. Just depends on what key you're in the mood to push. Natural log of 20, be sure to close it out, divided by natural log of 14, and we get the same dang thing, 1.1352. 14 to the first power gives us 14. 14 to the 1 point, and just a little bit more will give you a 20. So what do you raise 14 to make him be a 20? 1 and a little bitty bit. Let's look at number 17. Log of 0.4, base 0.4 gives you 16.4. So what do you have to raise 0.4 to make him be 16.4? The decimals are a little hairy. I don't want to get in the weeds with that. So let's just find the answer. Common log of 16.4 divided by the common log of 0.4 will give you the answer. Or you can use natural log of 16.4 divided by the natural log of 0.4. So let's go with natural log. What the heck? Natural log of 16.4, be sure to close it out, divided by natural log of 0.4, and we are getting negative 3.0528. Negative 3.0528 is our answer. So 0.4 raised to the negative will make this decimal a bigger number, 3.0528. So we're getting that. And if you're not sure, you can check it. You can do 0.4 humpy, negative 3.0528, and looky there, you get 16.3995, so rounds to 16.4. I need to be doing this squiggly line, approximate, or sometimes you see it like that. You see all kinds of variations, because when we round, we're not getting an exact answer. So this is approximately. All right, number 18, we're doing the log of pi, base pi, give us 57. This is about 3.14. We're asking ourselves, what do you have to raise 3 to make him be a 57? So you know that 3 to the third power equals 27. 3 to the fourth power is 81. So we're in that neighborhood, somewhere around in there. We don't have a log base pi, so log of 57 over log of pi, we'll use our key, our pi key, which is along this left-hand edge. Or you can do natural log of 57 over natural log of pi. Let's do logs this time. It's going to be approximate because we're going to round. So log of 57, close it out, divided by log of the pi key, is just 2 below there, 2 floors down, and that equals 3.5319, if you round that 8 up to a 9. So somewhere between 3 and 4, we got somewhere between 3 and 4. You can do it with natural logs, you get the same exact answers. Imagine you figured out by now. And I'm going to go listen to the thunder for a little while. Have a good day. See you next time.